Okay, class, welcome to part 2 of the 1.1F lesson. So we are on page 31 in the module, and it looks like 17 through 24. These are excellent questions to practice with. They kind of start easy, and then they kind of grow in difficulty. Okay, so pretty much I hope you're starting to see that solving for the absolute value uh, variable, if it's inside the absolute value bars, it's very, very similar to the steps that you would take to solve for an equation. There's just a slight change at the end. Okay. A couple things to remember. If there is a negative outside of the absolute value bar, you are not allowed to distribute. A lot of people see this minus and the negative, and they think that this is a plus. You cannot do that. You are not allowed to distribute inside the absolute value. Okay, so I draw them extra, extra tall, extra, extra vertical, and you just have to realize that you cannot distribute in. You always should just calculate what's inside first. So here I get the absolute value of x minus really 17 is equal to 3. Okay. Notice I just changed the negative 17 to just positive 17. Okay, so then I add 17 to both sides, and then I get the absolute value of x is equal to 20. So once I have the absolute value bars exactly perfectly isolated like this, there's nothing else to do. There's no constant. There is no coefficient in front. I then am able to split into two answers, and that's my final answer. Okay, you always want to split as your kind of like your last step. Okay, let's skip to number 20 because it looks interesting. So 20, I see that there's a negative outside of this group, which we are allowed to distribute into. But like I said, you are never allowed to distribute this negative into that absolute value. So it's kind of like you have to be very, very comfortable and understand what we're doing. We are distributing the negative, but we're not distributing the negative inside the absolute value. So this becomes 3 minus 5 plus the absolute value of x is equal to 6. That looks so kind of tricky. That looks kind of intense, but I think the moral of the story is if you just kind of follow what you know, follow the rules that we've always been using, this will be okay as well, right? So here I have the absolute value of x on the right side this time. That's okay. I'm going to add 2 to both sides to cancel the coefficient. I'm sorry, the constant. And I get the absolute value of x is equal to 8. Once I have it totally kind of set like this, this is where you do the split, right? You split into two separate answers. The first one being exactly the way it looks like, x equals 8. The second one being the opposite of that first initial answer. And kind of box your answers this way. All right, just take some practice. Look at something like 23. 23 is just a trap just laid out in front of you. They want you to think that you can distribute the negative. Just say it one more time. You must never distribute a negative into an absolute value bar. Because basically an absolute value bar should never be manipulated by outside terms, right? So here, really, this is kind of like saying something that's always going to be positive is set equal to 11. Or something that's always positive, right? The absolute value of negative a, it's always going to be positive. This term right here, no matter what it is, it could be negative 1,000. It will still be positive after. But since it's always positive, if you attach a negative outside, it will always be negative. So a negative to something that's always positive should be negative, right? And this question is really testing your logic and understanding of, is something that's always going to be negative ever going to be 11 then, right? The negative term, the opposite value of something that's always positive, should never be negative. Should never be positive. I'll say that one more time. The opposite of something that's always positive cannot be positive then, right? So this should be negative. This should be negative. And the fact that it isn't negative means that this is a no solution example, right? Okay, last one. Let's do number 24. Okay, again, I see a negative outside of a group. So I am going to attach the negative in front of the absolute value and to that -4. So I get negative absolute value of t plus 4. And then I can bring the 9 down. Really, the 9 is just combining with the 4. This equals 15. Okay. So I'm going to combine the 9 and the 4, and I get negative absolute value of t plus 13 is going to equal 15. Again, our goal is to isolate the absolute value. So I subtract 13 from both sides, and I get negative absolute value of t is equal to 2. And really, it's like the same exact scenario, right, as 23. If something is always positive, but you attach an opposite sign outside of it, then that means this should technically be negative now, right? The negative of a positive is always negative, but you're setting it equal to a positive. So this already should make you realize this is not possible, right? So this is another example of a no solution situation. And absolute values can have no solution if you just set it equal to a negative, right? So you would say an absolute value expression must always be positive. A negative in front of an absolute value must always be negative. Expression must always be negative. And if it's neither of these situations, then you know that something is wrong with your absolute value equation, right? An absolute value expression must always be positive. Therefore, if you put a negative in front of it, this expression should then always be negative. And if there's a mix and, an imbalance or something that's not right, like in this example, if a negative of an absolute value is a positive still, that's not possible. Anything that's not possible should be deemed no solution. Okay. There are tons of extra practice problems. There are some problems that I skipped in this video. I highly recommend that you try them. As always, the notes are posted on the calendar if you want to refer to them. And I'll see you in class. Thanks for watching.